Hey guys, welcome back to my bench. Today we're going to take a look at how to change frequencies on Mosley 6000 Series STL. STL stands for Studio Transmitter Link, and this is how we get our audio from the studio site to the transmitter site. There seems to be a little bit of confusion on how to do this. And the confusion generally comes in just because the instructions are cryptic, I guess is the best way to put it. And they have a problem with they don't describe to you certain things in it that just the whole thing would make a lot more sense if they just took the time to describe them a little better. But I'm going to show you how to do it. It's really pretty easy. This is the inside of a Mosley 6010 Oral STL transmitter. These things have two versions or two ways of getting audio down to your transmitter site. The first one is through composite, which is back here. Right there. They have two composites, composite 1 and composite 2. The other way is mono, where they just ship it out. The audio is just a mono on the carrier and on the FM carrier. These are FM, wideband FM, 75 kilohertz as a matter of fact. And along with that, with the audio, also goes what they call a MUX signal, which is 26 kilohertz, I believe, for passing down commands to switch back and forth between your transmitter, different transmitters if you have them, and to turn on and off certain things in your remote control. And so we're going to test that and make sure it all works. In our case, we want this to be on mono because this is going to be our AM STL to replace the Marty STL8s. Here's a picture of an STL8. This is old, but they still work, and they're pretty good machines. In the transmitter section of it, you basically, up in this area up here is a fan. You got to replace the fan. Sometimes you have to go and replace the outputs, the RF outputs, or sometimes power supply. But that's about it. These things are kind of little rocks, and they work really, really well. So let's get the calculator back up here, and I'll show you. Right now, we'll take a look at this. Set you to record. Okay, you're recording. If we turn this on and put it on transmit, we can see we're putting out about let's put it on power, about 5.7 watts. It's approximately correct. And our frequency error is, it says 5 kilohertz, but it's dropping rapidly. You'll see here in a minute. It'll stabilize out. I don't know where exactly. Yeah, there. Up, back down. Why is it doing that? Okay. It should stabilize out to about 100, 200 hertz. Yeah, it's getting there. It has a heater inside of this little box right here, which I'll show you in a minute. But first of all, we got to figure out how in the world do you get into one of these things. Well, turn that off and I'll show you. This box right here is the RF transmit RF modulation box. And in order to get into this, and this is actually the way to get into it, you pry the corners up with a greenie or another little screwdriver until it pops. And yes, this is actually the way to do it, because you'll see that this little top piece here, this was supposed to have been there on this way, this little top piece here is just press fitted inside this little ridge around there. So that's how it fits, and that's the way it's supposed to work. Alright, so on this little box you've got your baseband output comes out of here. It goes into the baseband input, goes through all of its rigmarole, comes out the RF, goes into a little filter, and into the RF amplifier back here. These can be a pain. They have a little, some of them, most of them, have a little IC in there. It's about that wide, has 4 or 5, maybe 5 pins on it. And they don't generally go bad, they just go weak. And you're supposed to, these are supposed to be between 6 and 7 watts out. You saw this one is about 5.7, so that's about right. But if you ever have problems with them and you just got low output, look at that guy in there, because that's going to be one of your big problems. But that's not what we're worrying on today. Today we're going to turn this on and let it warm up, because there's the little crystal heater right there. That if we look at this, bring you down here, and let's see if we can get some light coming from a different source here. Okay, this is a crystal heater. It's a crystal with a resistor in back of it that gets hot and it keeps it hot. That's basically all it does. This is the very fine tuning adjustment for what we're going to do, and these are your set switches, which are the ones that seem to confuse people. So let's go back up here and okay, so let's take a look at what how this thing works. In order to set these switches for the frequency that you want, the correct procedure is to subtract your frequency that you want out of this. Right now this is on 944.5. You subtract the frequency you want from 1020 or 1 gigahertz, 1.02 gigahertz, which we'll do on the calculator. So we've got 102,000,000. So we got 1 million or 1,020,000,000 cycles, 1.02 gigahertz. From that, you subtract your frequency that you want it to be on, which in this case, we're going to show how this is working now. It's 944,500,000 hertz, 944.5 megahertz, close to a gigahertz. So we take that, we end up with 75,500 megahertz. Now, what they tell you in the book is to put switch 1 on 64 megahertz. Well, there ain't no switch 1. If it was, and some of them there is, we'll see in the receiver. Some of them there's a switch right over here that has 64 on one side, nothing on the other. You never touch that. This one is fixed. It doesn't have that switch. It is a given that it's 64 megahertz. So we subtract 64 megahertz from our 75, and that leaves us with 11,500,000. Okay. The way these switches are set up, this first one is in increments of 4 megahertz. This one is in increments of 250,000 hertz. And this one is in increments of 25,000 hertz. So first thing we do is we look at the 4 megahertz one, and how many times can you get 4 million into 11,500,000? Well, 2. So 2 times 4 is 8. So we'll subtract 8 million from that. Right there, okay? And this switch right here would go on 2. 2 times 4 is 8. That's this first switch right there. Alright, so we got that one set on 2, which it is. Now, we have to find out how many times you could take 250,000 into 3,500,000. So we divide that by 250,000, which gives us 14. An even number, 14 for this frequency. Excuse me. So this second switch here, which starts at 0 and goes around to F, just like this one does. 14 would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A is 10, B is 11, C is 12, D is 13, E is 14. So this switch is on E. There's a little arrow here that you can just barely see pointing to it. Alright, and because we have nothing left over for the 25,000 hertz, this switch goes to 0. Okay? So that should be right there. Okay? So let's turn this thing on to transmit. And take a look at our machine here. Put it on power. We got 5.6 watts. And our frequency error is 25 kilohertz high. Well, interesting. So if we've got 25 kilohertz high, then why don't we just take this last switch and flip it down there to one more, which is 25 kilohertz, because that's just what it is. Well, there you go. So now we've got it on 1. Regardless of what our calculations say, you got to make sure that it's on there. So we're about 50 hertz off. I think that'll do. 0.05, yeah, so it'd be, yeah. Which is fine for this. Now, if we needed to, we could adjust it here. Well, all right. That's how this one is set up right now. We have to change frequencies. And the frequency we want is 947.850, I believe. 947.850. Yep. So we need to change frequencies to 947.850. So we'll turn off the transmitter. We'll clear everything out here, and we'll go through our setup here. So we've got 1,020,000,000 hertz right there, minus 947.850 right there, and that gives us 72,150,000. We got to take away the 64 million, 64 megahertz for those who are insistent upon it, and that would give us 8,150,000. Okay, so 8 million, 4 times 2 is 8, so then we're going to leave that switch alone, and divide, minus our 2 times 4, which is 8. That's going to give us 150,000 left over. Well, 150,000, you can't divide 250,000 into that at all, so you end up with this switch being on 0 right there. Okay, we'll explain the little red light in a minute. And so we got to find out how many times we can get 25,000 into 150,000. So we divide that by 25,000, and that would equal 6. So this last switch is going to go on 6, right there. All right, so 2, 0, 6. Right? Okay. To start with on 6. So we turn on the transmitter. Well, first of all, turn it off. Set the frequency to 947.850. Enter. Turn on your transmitter. Go to power. We got nothing. No power at all. Why? Okay. You haven't done one step here yet, and that's very important. What you do is, let's take you and bring you back here. On the front meter here, you've got positions for everything you'd want to know, right over here. You got plus and minus 15, 12 volts, 5 volts, local oscillator level, AFC level, IPA level, PA current, forward power, reflected power, program level, and MUX level. So what you do is you put it on AFC, and if you can see that AFC is pretty low, the book says all you have to do is adjust your AFC to get it into the center. Yeah, and the AFC light is red. See that light right there? Same as that light back in there. Alright, so you take your little diddling tool, if you can get it in there somewhere. Why can't I find it? There we go. And you bring this up so that it is centered, mid-scale, and it reacts slowly. So there's mid-scale. It took a few twists, and now we look over here. Our AFC lock light is on. Our red light over here is off. And now we will turn on the transmitter. And look at that. We got 5.47 watts output. And our frequency error is 25 kilohertz again. Isn't that amazing? All right. So let's take our number 3 here, bump it up 1. So that gives us minus 50 because we were off 5. Well, let's get our little diddling tool right here on this thing here, which is the fine adjustment, and very touchy this. You want to do this after it's been warmed up. Wrong way. After it's been warmed up for a little while, because you saw what happens. Alright, there I got it. Wow, it never happens that quickly or simply. Plus and minus 0 kilohertz. So we are dead on frequency on this thing on 947. See it over here? 947.850. Right dead on frequency. And you can see the AFC light is lit and the radiate light is lit. We'll take a look over here. Our AFC level is still in the center. Our IPA level is in the center. Our PA current is whatever 5 means. These are, they don't mean a whole lot, these things. Forward power should be up right around 0 level where it's at. Reflected power into my dummy load, which is inside that thing, is nothing. We don't have any program level. We'll get that next. And our 5 volts is 5 volts. Our 15, well, that's off a little bit. I gotta do something. Well, that's 12. Still off, it's 11. 15 plus, 15 minus. This one doesn't have, this is an older version, and it really doesn't have as much control over what these are meter settings. Setting the 15 volts is not that easy. Anyway, we're still good. We're still transmitting at the right frequency. Everything is right. Okay, that's how you set the actual frequency for one of these guys if you need to change it. Now we've got a couple of other things we've got to do. The first thing is we've got to where is my little, who's it? I thought I was ready. I'm never ready all the way. Okay. We'll plug into there. That's plug it into my yeah, audio generator. We'll give it 600 ohms. It's 600 ohms out of the generator, and I got to turn on the generator. Forgot all about that. And that is number 2. Okay. So we'll pretend that didn't work at all. Okay, so we're recording. Anyway, turn it back on. So we've got we're good on everything. Now we're feeding it audio out of that right there. And our program level is 0. That might be just a tad high. Yeah, just a little bit. We'll just leave it at 0. Okay, anyway. But what we want to see is over on the little scope here. If we can see it. Okay, we'll just set you down in there. Whoops. There is our frequency on the scope. And right now we're on wide bandwidth, and we're looking at, about a little less than 50 kilohertz. Give it a little more. There's 75 kilohertz right there. So we can tell that this thing's working. It's not going out of lock, and it's still on frequency. That's good. Now, the only other thing we got to do, turn it off. The other thing that we got to do is we've got to take another one of these little cables here, and we need to feed this thing 26 kilohertz. Now, the only thing I got that does 26 kilohertz is this. Okay. These things aren't fantastic, but they work. Alright, so we'll turn this guy on, and we'll set her for, let's see, I want you down to 0. You to 26 kilohertz, 2.5 volts. That'll be good enough. And that's on channel A, main. It's a silly way of putting it, but we'll feed that into the mux input. One end goes to ground, one end goes to here. Ugh. Come on, you can do it. That's our mux input. And I don't have anything. Why not? I think that's mux.
No, that's composite. Stupid.
Okay. That's composite out. There's mux in. Alright. So start you back up again. Bring you over here. And okay, these switches kind of go bad. Alright, so I got a mux input, and we want that down around 5. Let's see. And let's see what it takes to get that down around 5. Yeah. Come on, switch. All right. Right about there. We're looking at, what, volt and a half? And 1.5 volts. And I believe that's peak. So, anyway, so the mux is working. That's all we're going to do with this one. I'm not going to play with any of the rest of it. I'm just going to pretend that it works. Not really. I mean, the thing was in service reasonably ago, so I'm pretty sure of it. The one other thing I wanted to show you was this. When you switch these things over, let's turn transmitter off, that's good. When you switch these things over, you've got a bunch of little jumpers that you have to play with here, and they're all marked. Where are they? Well, let's see. Here's mono and composite here. Here's your phase select, that doesn't count. Mono and composite here. This is your low pass filter. We use that, it stays in. I thought there was another one. This is pre-emphasis, it's in. There's not as many on the transmitters or on the receiver. But anyway, this is, you have to make sure you switch these or you're going to be composite in, not mono in. So, we got that guy done. For now, we'll take this and we'll check one more check after we get done here, because we're going to put on this guy. Ooh. And you basically squeeze it together. If you haven't got strong enough hands, which I'm getting to the point where I don't really, okay. You turn it back on again. Wait for the AFC light to come on. It went green. Turn it on transmit. Now see how it's drifting around? Once it warms up, it'll get close to back to where we want. But this is why they left a hole in the top, because once you put this cover on here, you have changed the capacitance of this touchy device. So, let's see, it's been climbing for a little bit. Let's see where it goes. It's going on the negative side, should come back down. It'll stabilize itself out. It is a PLL, and it's up to 400, 430, 420. Let it settle a little bit. And it just shifted gears on us, so it went to, that's still at 0.3, 0.25. Alright, so we'll record this. Here we go. So, after a few seconds of it warming up and settling down, we're still darn good here. We're swavering around a little bit between 170 minus 150. I want to watch it just for a little bit and see what it does. Alright, so we can go in here, and just me putting the tool in there did it. I'm not going any... Yes, no? Oh, touchy. Whoops. Way too far and I didn't even feel it turn. We're leaving it there. Okay, so basically we're at what? 20, 30, 20. Alright. So that's right, but I did have to touch up this little guy here. Alright. That's done. For now. We will disconnect this and set it aside. And one thing I do have to do, if I can find my stuff, what I do with it, I got to get some new double-sided sticky tape to stick this down, because yes, that's the way this is held in, and that is the way it was held in. I got some around, here it is. It's not like these things get moved a lot, but they still, you know. Okay, so that one is still on there. Those guys are completely off. Alright, so we'll go over to here. Unfortunately, you got to build this up, because finding those pads, I think a wonder here, is not a simple task. I think one more chunk ought to do it. Probably. Come on. There you go. Alright. And we'll do it over here on this end too, in the same place as the pads, because there's some sort of little hold down thing that goes there, but I've not seen one with it. We'll see from the receiver how they did it on the newer models. It's really kind of comical. It was like some guy in the back room went, "Hey, I got a way of doing this that won't cost us much." And everybody said, "Yeah, hey George, that's a great idea. Let's do that," and punish everybody for the rest of time. Alright, so that's cleanish. Yeah, it's just gooey, sticky. Maybe it's a good thing it's gooey, sticky. Anyway, we're going to stick that down there. That won't move. Alright, so let's take this, get it out of the way. I'll be back in a minute. I got to go get the receiver. And we're back. Okay, this is the inside of a Mosley 6030 Oral STL receiver. Went along with that transmitter that we just got done doing back there. And this one needs to be set up for to receive the 947.850 that we had the other one set for. To be honest with you, I have already done that, but I wanted to show you how this is done on this one because it is slightly different. What we do is we unscrew them from this goofy thing they got here. Basically, if you look down here, they've got a couple of plates that go across and are screwed down with a couple of screws that, if I can get down in there and show you, if you look right down in there, you'll see that that plate, it just kind of overlaps the metal from the case where it sticks out, where the top goes over it, and it just holds it down. It is not what I would consider to be a phenomenal way of doing things, but it does work. I've never had them fall out, but they're kind of heck to put back in. Anyway, so we got to get these out. Now, this is a receiver. It's a little more complicated than a transmitter. So we'll unscrew these guys, move the little plate out of the way. It is out of the way as far as it'll go. And it's the same thing over on this other side. You get those loose, and then you can kind of wiggle these guys out. Alright, the one we're working on is this one. This is the RX RF module, and it's not quite as free as the rest of them go, but it's the same thing. To get the top off, you prise with a little screwdriver under here until it pops off. Yes, it's the right way to do it. Okay, that came off. We'll set him aside for now. And if we look inside of this thing, we can see it's kind of like the other ones. It's like the RF module, the transmit RF module. However, if we look over here on this side over here, bring a little light in the subject if I can. Alright, so basically we've got the PLL chip, as associated stuff, our three little switches. This is the same thing as that tuning cap that we used, only it's all sealed up in there. But it's got the crystal in it. This is a full TCXO, so frequency-wise, it's quite a bit more accurate. It's not as drifty as the other one. And these are the switches I was talking about right here. On this receiver, you've got this 64 megahertz switch right here, okay? And it has a no and an on. Basically, for the 900 megahertz version of this, 950 megahertz version, you leave that on, period. That's your 650 or 64 megahertz, just like our other one was. However, now, let's see, get you back up here. All right, so let's go over to the calculator, and I'll show you what the difference is in this. On the receivers, you start off the same way. We want a frequency of 947.850. So we take our 102.0000000. 1,020,000,000 hertz. Okay, 1.02 gigahertz. From that, you subtract your frequency, which is 947 947,850,000. That equals 72,150. This is a receiver. Can you think of what you need on a receiver that you don't have on a transmitter? If you said IF, you're right. You have to add back in your 10.7 megahertz IF, because it's going to subtract it in the on the mix down. So you put in the 10.7 megahertz IF, and that equals 82,850,000. Now we subtract our 64 megahertz. 64 megahertz. And that equals 18,850,000. Well, we got our 4 megahertz over here. So we go 4 megahertz. What can I do with 4 megahertz? 4 times 4 is 16. So that would be 16 megahertz on that one, because 18 is not enough. Okay? 6 times 5 is, or 4 times 5 is 20. So we're in the middle. So we have to take away our 16 megahertz, which that would be a 4 on here. 4 times 4 is 16. And that leaves us with 2,850,000. Okay? So 2,850,000. We want to find out how many times 250,000. Our second one here, we'll go into that. 250,000 equals 11.4. Okay? So what you have on this one would be 11. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A is 10, B is 11, so it's set on 11. And 0.4, we're going to guess, because just like the other one, you have to make sure you're right. And there's a couple of ways of doing that. If we went back here to our 18,400,000, come on, I thought you could do this. There, 18,850,000. From that we subtract our 16, whoops, missed a button, 16 million. That leaves us our 2,850,000. Since we know that it's 11, so we subtract from that. Let's see, how do you do that on here? Does this have, no, it doesn't have parentheses. So what is 250,000 times 11 equals 2,750,000. So we take our 2,850,000, subtract 2,750,000, and we end up with 100,000 divided by 25,000 equals 4. So the 0.4 is a 4. Well, it would be if you think about it. Wow. Okay. Anyway, so we're going to start off by setting this at 4. 4, right there. All right. I already have my, come on. All right, I've already got my generator here. Oof, if I can get this thing to sit still for me. It's very hard to do this because there's just not enough room. Okay, I've got my generator set up at 947,850. We're going to give it some modulation, just some, and we're going to give it enough signal to lock it in. Remember, you got to go through and do your adjustment of your AFCs the same way on this one as on the other. You put it on AFC, you get it to the center. All right, so let's see, minus 40, that's 11. It should cut in, okay? So right now, we're giving it about 35 microvolts. I'll bring you out here. This is the RF level. 35 microvolts is right out there. Now, these have a setting on them for squelch, and the squelch is set for approximately 20 microvolts. Approximately. So, you can see that AFC is locked. We are receiving. Our RF level is, well, you know, whatever that is for this thing. And we're feeding it about 35 microvolts right now. So let's see if we take this down to about 20. I'm listening for the relay. Okay, there went the relay at about 10, 9.6. And you can see the signal level has dropped down to there, and the signal is off. Now, I'm going to slowly turn this up to 20. Oh, I missed it. And it is right there is where it hits in. It's about 15. We're green, and we're at there. All right. That's how you do the receivers as far as setting up the frequency goes for them. I'm not going to go through a whole alignment on this thing, because, quite frankly, it takes a long time. But basically, it's nothing more than just a receiver. It comes in from the back and goes out and all that kind of stuff. What we are going to do, though, however, is going to turn this generator off. Signal is off on here. And in back of me, you can't see it. I don't know if there's enough battery left in this thing to do this, but we'll try. In back of me, I've got this guy set up. The transmitter is set up with 2 inputs out of this thing. I got the 26 kilohertz mux and audio. I'm going to turn it on. It's transmitting on our frequency. And I'm going to come back over here and look. It is, the green light is on, and our RF level is high enough to get past the squelch. Cool. So, now, turn that off real quick. Oh, batteries don't last very long. So now what we want to do is we want to look at our mux level back here. I need a... This is not the bestest way of doing this, but it is one of the easiest ways of doing this. Can I get that from there to there? Yeah, I guess. Alright, so this doesn't have... Yeah, it does have mux out. If I go over to here... Excuse my back. Okay, I'm feeding it in mux 1. And I need a little bit more signal here somehow. Let's see. If I just pull this off and stick a clip lead on it, I'm feeding that transmitter into a dummy load, so I don't have much to work with. Okay, so I've got my external input here. We'll go to AC on the input, and here we go. Please work for a little while longer. And if we look at our scope, we can see our mux level right there. So if I take the mux level and turn it down, let's see, turn it down. There, it's off. See, it's going. And I bring it back up again. Okay, so we know the mux is working, and I guess we know the receive is working. We'll find that out the easy way. We need basically a speaker. And we're just going to cheat on the speaker here. Got a little amplified thing that I built over here on the side. And we're going to connect that to our audio out, which is, ouch, which one's audio out? Mono out is right back here, plus and minus. See what my program level is. My program level is at 0. Why have I got this thing buzzing so bad? There. Bad connection. Alright. So, you can hear that. My program level is dropped considerably. Bring it back up to 0. Okay. Now, we only have one other test to do. Turn you off. Turn you off. Get another thing here. And yeah, this is flat out cheating. don't even know. Do I have one like that? I wonder. Yeah, this will work. All right. What we have to do is we have to look and see what it looks like as far as how clean it looks. And what are we on? 1 kilohertz. And whoa, okay. I'm just peeking this thing. It's touchy. Okay, take it here. We want to make sure that we are less than 1% distortion, or as good as we can get. Now, around here I can read about 0.1 is about the best 0.1% distortion is the best I can do. If we take a look at the meter here, we're swaying about a bit, and we're on the 0.3 scale, but with this conglomeration of wires I got, we're looking at less than 0.2.5. I might be able to get that down. Whoops, too much. Like I said, this thing is touchy. Come on. The new ones do this for you. That's about the best we can get. But I can guarantee you that that is down under 0.1. It's just what I've got for the mess I've got going. So, what we've proven is that the transmitter transmits on the right frequency, the receiver receives on the right frequency, the mux signal goes through like it's supposed to, and on 26 kilohertz, and that our audio is clean, coming from the receiver through, or the transmitter through the receiver and into here. That little generator I've got, that 0.2 is about the best it'll do. They're not that clean. They just aren't, but that's what I got over there because I had to feed it 2 signals at once, and that thing will do it. Anyhow, that's how you do it. Like the other one, only in this one there are lots of them. Here is a mono. Here's a mono switch. This is mono. This is a mono jumper. That's a mono jumper. That's your low pass filter. Thought there was one more in here someplace. So there's 1, 2, 3, 4, 5. No, I guess not. Anyhow, like I said, I'm not going to go through a whole alignment of this right now. I just wanted to show you guys how to change the frequencies, and that's how you do it. This is fine. Anyway, that's it. Oh, and here's your AFC level adjustments right here. Those are the ones that you use to get your AFC up in the middle of the meter, just like the other one. You just turn those until it comes up to 0. Anyway, that's how you do it. That's how you set these things up. You do the transmitter, get the AFC level set up right. Then you do the receiver with your switches via the calculator, what we just did for calculations. You diddle with this one and the frequency on the transmitter. This one you don't have to diddle with the frequency because it is much more accurate than the transmitter is because of this TCXO. And just make sure that you're good on here. Check your mux levels in, check your RF in, and set it for about 20 microvolts mute adjust right here. For your mute adjust for about 20 microvolts. Anything below that, it's going to be such a lousy signal you'll never be able to use it on the air anyway. So you want these things to read at 0 or above anyway when you're pointing at them, so that you just swamp the front end of them. But that's how you do it. leave these alone. Don't touch them. If you have to do anything, there's some stuff under here, but I'm not going through that right now. Anyway, there you go. That's how you do it. If you like the video, give it a thumbs up that way. And thanks for watching, and don't forget to subscribe.